Welcome to Manifested Publishers.
Hello, my dear student. My name is Dickens Mugalo, and I welcome you to today's lesson. And in today's lesson, we are learning about branching isomerism in alkenes. We already saw from the previous lesson that alkenes exhibit both branching and positional isomerism, and we saw that positional isomerism occurs when the position of the double bond changes. And then we were able to look at some examples on how to name positional isomers. So in this lesson, I want us to look at branching isomerism and how to name branched isomers of alkenes. So we start by looking at the rules of naming branched alkenes. Rules of naming branched alkenes. So the rules are simple. The first one is you identify the longest carbon chain containing the double bond. Identify the longest carbon chain containing the double bond. That is the first thing you do. But as far as alkenes are concerned, we said the longest carbon chain is the one that contains the branch, that contains more carbon atoms. But for the case of alkenes, the longest carbon chain is the one that contains the double bond. Then rule number 2 is that number the carbon atoms from the end that is near the double bond. And remember, when naming, you should always make sure that you have given the double bond the lowest number possible. Give the double bond the lowest number possible. That's rule number 2. The last rule is you indicate the position of the substituent group in the name. You indicate the position. In case we have a substituent group, it is always good to indicate the position of the that substituent group or the branch. So we now look at examples of branching isomers. So we look at examples. First example is as follows. So first one is draw and name branching isomers of alkene with the formula. Draw and name the branching isomers of alkene with the formula C5H10. So the first thing you do is you start by drawing that alkene that has 5 carbon atoms. So we shall start by drawing the carbon atoms like that. There are 5, and then you locate the double bond between the first 2 carbon atoms like that. And then Remember, when you are drawing the structure, each carbon should have a total of 4 covalent bonds. So the second one, we are adding one more bond. The third one, we add 2. Fourth one, we add 2. Fifth one, we add 3 bonds. So that will make sure that each carbon has a total of 4 covalent bonds. Now, when giving or naming the carbon atoms, we always should label from the end that is near the double bond. So the double bond is near the left hand side. So our numbering will be from the left going towards the right hand side. Therefore, we get this alkene. So therefore, the correct name will be based on the position of these two, the position of the double bond. The double bond is between number 1 and number 2, and the parent name is having 5 carbon atoms. Therefore, the name will be pent 1 and then in. Remember, from rule number 1, you have been told the double bond should be given the lowest number possible. So now that it is between 1 and 2, the lowest number between 1 and 2 is 1. Therefore, we get that name, pent 1 in. Now, if I was drawing positional isomers, what I could have simply done is I could have simply moved this double bond from carbon 1 and carbon 2 to between carbon 2 and carbon 3. But we are looking at branching isomers. That means we have to form substituent groups, and the best substituent groups that we can form are methyl groups. So how do we do that? We consider the carbon atom on your extreme. That carbon atom contains 3 hydrogen atoms. So we form a methyl group and replace any middle carbon atom. So the middle carbon atoms that are left are the carbon atoms labeled 2 and 3. Therefore, I will replace any of these hydrogen atoms with this methyl group. That will give me an isomer, just like we learned under alkene. So the new parent will have 4 carbon atoms. So I'll draw the 4 carbon atoms like that. Then I put the double bond between number 1 and number 2. Then I indicate the original hydrogen atoms. But we have been told if you want to form an isomer, you replace any middle carbon atom. So any middle hydrogen atom. So we are going to replace this one here with a methyl. So I put there a methyl, this one here. Then this space will be taken by this hydrogen. So it's like there is an interchange. So this one remains hydrogen. This one remains hydrogen, like that. And then, okay, we have this hydrogen, this one. Then the last carbon has this hydrogen. It has this hydrogen. And the one that has come here, there is an interchange. So like that. So we shall form that isomer that will have a total of 1, 2, 3, 4, 5 carbon atoms and a total of 1, 2, 3, 4, 5, 6, 7, 10 hydrogen atoms. Now, when giving the name, we follow the rules that we have just mentioned up here, that you identify the longest carbon chain. So the longest carbon chain is this one because it has the double bond. And then from that, you number from the end that is near the double bond. If I was talking about alkenes, then this rule was telling us that we number from the end that is near the branch. But here, as far as alkenes are concerned, the rule now changes. You name from the end that is near the double bond. So the double bond is near the left hand side. So this will be labeled as carbon 1, then carbon 2, carbon 3, and then carbon 4, like that. So we have numbered. After numbering, you can now try and give the name, putting in mind that we have a substituent group here, which is a methyl. And this methyl is attached to carbon number 2. Therefore, the correct name for this compound will be, this methyl is attached on carbon 2, so the name will be 2- and then methyl And then the parent now has 4 carbon atoms, and we know that alkane that has 4 carbon atoms has a prefix of but. So that is what we start with. You put but, then dash. You show the location of the double bond. Double bond is between carbon 1 and carbon 2. And we have said we give it the lowest number. So between 1 and 2, the lowest number is 1. So it is but 1 and then in. So therefore the correct name of this branched alkane is 2-methyl-but1-ene. You can see these 2 compounds have the same molecular formula. When you count the total carbon atoms in each, there will be 5. Total hydrogens in each, there will be 10. But the structures are different. Therefore, these 2, we call them isomers. We can still form another isomer from this one here by simply forming a methyl group from the last carbon atom. And remember, we have said it is only possible if this carbon atom, this methyl group is replaced by any. Now, you realize that if I form a methyl group from this carbon with these 3 hydrogen atoms, then I'll be left with these 3 carbon atoms. Then you can see we no longer have any middle hydrogen atom. Instead, we have this methyl. So we are saying that we cannot form another isomer by forming a methyl group from this. Instead, we can move this methyl group from this position up to this position. That will still give us another isomer. So this is what I mean by that. So we shall draw this compound here. What is going to change is the position of the methyl group. So I'll have my carbon atoms. They are 4 in the parent chain and the double bond. Then I'll have hydrogen. Then I'm simply going to interchange this hydrogen. I replace with in this position here, and then this hydrogen will be replaced by this methyl. So the methyl will take the position of this hydrogen like that, and then the rest remains. Putting in mind the fact that each carbon atom must have a total of 4 covalent bonds. Now the name, the rules are here. You number from the side that is near the double bond. So the double bond is near the left-hand side. The numbering will be the same. So this will be carbon 1, carbon 2, carbon 3, and carbon 4. After which, you should be able to give the name of the parent. The parent is having a prefix of but. And then we have a methyl attached to carbon 3. So therefore the name will be 3-methyl but1, and then in but1-ene, because the double bond is between carbon 1 and carbon 2, but we give it the lowest number. So therefore these are the isomers. These are the branching isomers, because we have a branch or a substituent group of this compound whose molecular formula is that. Next, I want us to look at another example. Example 2. You draw and name. Draw and name branching isomers. Draw and name branching isomers of alkene with molecular formula of C6H12. So let us see how many isomers can we come up with from that molecular formula. So the first thing you do, my dear learner, is you first of all draw that alkane that has the 6 carbon atoms and the 12 hydrogen atoms as follows. So we shall draw the 6 carbon atoms like that. So those are 5 and then 6. And then you fix a double bond anywhere. You can fix anywhere. It can be on your right or your left or in the middle. So let's try and put the double bond in the middle there. And then you complete with hydrogen atoms, putting in mind the fact that each carbon atom should be bonded to 4 atoms. So the first one, we are going to add 3 bonds. Next, we shall add 2, one up, another one below, like that. The next carbon has 3 bonds. This is 1, 2, 3. So we are adding one more to make it 4. So we add one more here. Then the next one has already 3. This is 1, 2, 3. So we add one more to make it 4, like that. And then the second last has 2. So we are adding 2 more, one up, another one below. The last one has 1. So we are adding 3, like that. So that is the first isomer that we come up with. Now, when giving the name, remember the rules are clear. You number from the end that is near the double bond. If you look at that structure keenly, my dear learner, you can see the double bond is in the middle. So you can begin to number from the right going towards the left, or from the left going towards the right. So let's start from the right going towards the left. So this will be labeled as carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and then carbon 6. Or if you start from here, this will be carbon 1, carbon 2, carbon 3, carbon 4. You see the double bond is between carbon 3 and carbon 4. So you can begin numbering from either side. So after numbering, you give the name, putting in mind the location of the double bond. Double bond is between 3 and 4, but remember you pick the lowest number. So from this structure, we have 6 carbon atoms. That means that alkene that has 6 carbon atoms has a prefix of hex. So therefore, the name will be hex, then the dash. The location of the double bond is between carbon 3 and carbon 4. The lowest number is 3. And then you finish by the word ENE. So the name is hex 3-ene. So that is the correct name of that one. We can form other isomers from this by simply forming substituent groups. Those substituent groups can be obtained from the carbon atoms on the extreme ends. You form methyl groups and replace with any middle carbon atom. For example, I can pick this one here, this one. You replace. So after removing that one, you realize you'll be left with this 5. 1, 2, 3, 4, 5. And then you replace with any middle. Any middle carbon are these ones here. These 3 are the middle carbon atoms I'm talking about. Because after removing this will be at the end, then this will be at the end. So I'll have these ones. So these middle hydrogen atoms I replace with a methyl, this methyl group here. So let us see which structure shall we come up with. So I will have this. I'll have this structure. So this will be 5 carbon atoms. They have now reduced from 6 to 5. Then don't forget the double bond is now between these 2, like that. And then you fix the hydrogen atoms. This is hydrogen, these ones, hydrogen, hydrogen. Then these 2, we have hydrogen, then we have hydrogen. And then remember, each carbon should have a total of 4 bonds. So this is hydrogen. I'm adding 1 here, also add 1. Remember, we have said we are replacing the middle carbon atoms, the middle hydrogen atoms with a methyl. So I can choose to replace this one with a methyl, like that. Then this hydrogen that was here will now be on the extreme. Then I put these 2. So we have hydrogen and then hydrogen. So we have come up with another isomer whose molecular formula will still be C6H12, because if you count the carbon atoms, there will be 6, the hydrogen atoms will be 12. Let's try and give the name. The rules we follow, you number from the end that is near the double bond. So learner, if you look at this structure here now, the double bond is near our right hand side. So we shall begin to number from the right going towards the left. So this will be labeled as carbon 1, carbon 2, carbon 3, carbon 4, and then carbon 5, like that. After which, you can now give the name of that branched alkane. So the parent is now having 5, so therefore the prefix will be pent. The branch is located on carbon number 4. According to this numbering, carbon number 4, and that branch is methyl. Therefore, the correct name will be 4-methyl, and then 4-methyl pent. Pent means 5. Now, the double bond is between carbon 2 and carbon 3. Therefore, we pick the lowest number, which is 2. So this will be pent 2 and then in, like that. So that is the correct name. We can still also get another isomer from this. We can form a methyl group by simply replacing this end with any middle. So if I remove this one here, the middle carbon atoms are these ones here. So I replace this middle carbon atoms, this middle hydrogen atom, this one and this one, with a methyl. So I can either put the methyl here or here. Remember, the new structure will have a total of 4 bonds. So let us draw. So this will be carbon now having 4, double bond is here. Then I indicate these hydrogen atoms, the initial ones, hydrogen, hydrogen, then this methyl, then this hydrogen. Then what I'm going to do, I'm going to replace this hydrogen with a methyl, just this methyl here, CH3, like that. And then this carbon has this hydrogen, this one, but remember I interchanged, so this one comes here now, like that. So that is the new compound. The name, that's a branched alkene. The name, of course, we know the rules. You number from the end that is near the double bond. So the double bond is near our right hand side. Therefore, when giving the name, when giving the numbers, you start from the right going towards the left. And remember, you should you number the longest continuous chain. So the longest chain is this one that has many carbon atoms, including a double bond. So this will be carbon 1, carbon 2, carbon 3, and carbon 4, like that. That means the parent now has 4 carbon atoms, and then we have 2 branches. The first branch is on carbon 2, the next branch is on carbon 3, and they are 2 and identical. Therefore, the name will be as follows. The first methyl is on carbon 2, then the next methyl is on carbon 3. Then you put a dash to separate this number and the letter. We have 2 methyl groups which are identical, so therefore introduce the word di, and then you put methyl. And then we finish by the parent. The parent is having a total of 4 covalent, 4 carbon atoms. Therefore, we get the prefix but. So it is but. Now, double bond is between carbon 1 and carbon 2. Therefore, we pick the lowest number, and that will be 1. Like that. So that compound is called 2,3-dimethyl methyl but1ene. Now, suppose you are given the name and told to draw the structure. How do you do that? So that is forms the next part of our examples. We want to see how do you give the name, how do you draw the structure if you are given the name. So the next question is draw the structure of the following. Remember, we are still looking at branched alkenes. So the first one is, they have given us a name of 1-chloro-2-methyl. 1-chloro-2-methyl pent-1ene. Now, if you look at that name, this is another example of a branched alkene. We have two branches, or we have two substituent groups. We have a chloro and we have a methyl. The chloro is attached on carbon 1 and the methyl is attached on carbon 2. So how will the structure look like? So before you draw the structure, you identify the parent. The parent is pent. Pent means 5. So we have 5 carbon atoms. So we draw the 5 carbon atoms. 1, 2, 3, 4, and then 5. After which, you show the double bond from the name pent-1. It means the 1 is the lowest number, meaning the double bond is between carbon 1 and carbon 2. So it is now here, the double bond is there. Then we show the other bonds, putting in mind the fact that each carbon atom should have a total of 4 covalent bonds. So like that. Now, before you fix the hydrogen atoms, you look at the question. We have already seen we have 2 substituent groups. The first substituent group is attached to carbon 1, and that is a chloro. So that chloro will be put on carbon number 1. So on carbon number 1, I put a chloro, which is a Cl, chlorine. Next is methyl, and that methyl is attached to carbon number 2. And therefore, I check carbon number 2, I indicate there methyl. So carbon number 2 is this one, CH3, that is the methyl. After that, after putting the branches, you can now finish by putting the hydrogen atoms. So we are going to have a hydrogen. The rest are hydrogen atoms like that. Hydrogen, hydrogen, hydrogen atoms. So that is the structure of 1-chloro-2-methyl pent-1ene. Suppose you're also told to draw the structure of this one. How do you draw the structure? The second one is as follows. We have been given the name, and the name of that compound is 2-methyl pent-2ene. So they have given us the name. They want us to draw the structure. From this name, we should be able to identify and realize that we have only one substituent group, and that substituent group is attached to carbon number 2, and that substituent group is a methyl, and the parent is pent. Pent means 5. So once again we have 5 carbon atoms. So we shall draw the 5 carbon atoms as follows: 1, 2, 3, 4, and then 5. After drawing the 5 carbon atoms, you decide which side do you start numbering from. You can either be from the right or from the left. Don't forget, the double bond should be between, from the name, the lowest number that has been picked is 2, meaning The double bond is between number 2 and number 3. So therefore, it means we shall put it between these two carbon atoms here. So this is carbon 2 and that is carbon 3. And then the rest will be those single bonds. And then remember, when you're drawing that structure, always ensure that each carbon atom has a total of 4 covalent bonds. That's what we have done there. What is now left is, of course, the second carbon has 3, so we are adding one more. The third one has 3, so we are adding one more, like that. This one has 4 bonds. So after which you now indicate the methyl, and the methyl is on carbon number 2. From the right going towards the left, this is carbon number 2. So we put here a methyl CH3, like that. Then the rest will be hydrogen atoms, like that. Hydrogen atoms. So that is how we draw the structure of 2-methyl pent 2-ene. So we have come to the end of our lesson. I would like you to try the following questions. Remember, we have been looking at naming of branched alkenes. We have already looked at the rules. What is key is should be able to identify where the double bond is, and then from there you can be able to apply those rules, and then you draw isomers. Remember, isomers should have the same molecular formula but different structures, as you can see that. So just try the following questions. Try the following questions. So the first question is as follows. Question 1, draw and name branching isomers from the alkene with the molecular formula. With the molecular formula of C7H14. You realize we are going to have quite a number of branching isomers. They are more than 5. The next question is draw the structures. Draw the structures of the following compounds. So here you have been given the name, so they're asking you to get the structure. So the first one is 1 bromo, 3 ethyl pent 1-ene. Part B, try this one. 2 methyl, 2-methyl pent 2-ene. The third question is give the names of the following. So in the third question, you have been given the structure, you're told to give the name. So the structures are as follows. We have this carbon atom bonded to 3 hydrogen, the first one. The second one is bonded to 1. The third one is bonded to 1. And the fourth one has a bromine. And then the fifth one has the 3 hydrogen atoms. This is A, try that one. And then part B, Also try to give the name of this compound here, whose structure is as follows. We have the first carbon atom bonded to 2 hydrogen atoms with a double bond. The second one is bonded to 1 hydrogen atom. The third one has a methyl group with a hydrogen. The fourth one has a chlorine with a hydrogen. Then the last one has 3 hydrogen atoms. So just a clue here, we have 2 substituent groups. We have a methyl and then we have a chloro. So when giving the name, in that case, we can use alphabet. Between chloro and methyl, you realize chloro will come first in the dictionary, followed by methyl. So also try that one there. So we have come to the end of our lesson. We have learned that alkenes also show branching isomerism. And that one means we have substituent groups that occur. And when giving the name of that branched isomer, it is good we follow the rules that we have learned earlier, that when giving the name, you start by numbering from the end that is near the double bond. So I believe if you do that, you should be able to answer a question that comes your way. Otherwise, thank you for being a good student. I'll see you in the next lesson. Thank you.